Standardization and quantiles. Standardization is a way of comparing marks from various subjects where the tests all have different means and standard deviations. The distribution of marks is assumed normal, or at least it would be if a lot more people took the test, and the marks are standardized to the standard normal distribution using z is equal to x minus mu over sigma. Now we've discussed this previously. Z is the standard normal distribution, that's the normal distribution with a mean of 0 and a standard deviation of 1, and therefore a variance of 1 squared. X would be the normal distribution of the actual test, which has a mean of mu, and a standard deviation of sigma. So we can use this to transform the distribution we actually have into the standard normal. And that means that we can compare lots of distributions with different means and different standard deviations. This enables them to be compared as we just mentioned. A quantile should be a familiar concept. You have met one particular family of quantiles before, the quartiles. Other common quantiles are deciles, which split the data into 10 parts, and percentiles, which cut it into 100 parts. I've said the names are self-explanatory, but I explained anyway. An example might be a case of a test or an exam where we know that a certain percentage of students are going to fail, and we want to find the fail mark for a particular cohort. It might be the other way round. We might have a fixed pass mark and we want to know what percentage of a particular cohort pass. So we've discussed two concepts in here. The first one is the standardization. So let's suppose that this is the standard normal. Then over here, maybe a long way in the distance, we have a test which has a mean of mu and a standard deviation of sigma. And in this case, sigma is more than 1 because we can see that this is more spread out than this one. So by subtracting mu, that's a shift of origin, we take this one and we move it down here. So that now we have something down here that looks like this. And then we divide by the standard deviation, which then makes it the same shape. So we can take a variety of different shapes out here. So this one might actually be less spread out than the original one. But by subtracting mu, we move it back to the origin, divide by the standard deviation, and we make it into the shape of the standard normal. And the second concept over here was the cutting the data that we have into different quantiles. So with quartiles, might have lines here as such that this area, this area, this area, and this area are all equal. On the other hand, it might be a fixed percentage of students we know are going to pass an exam. For example, we might decide to pass 60% of them. We know from symmetry that 50% this side. So we would go here, so that 10% of the data is in here, and then we'd have 60% passing, and we'd need to find this pass mark just here. So two different concepts explained here, but clearly related concepts all to do with the normal distribution.